Okay, so this is test B, and we're going to go through the back side of test B, which is the open response portion. I suggest if you have test A, just follow along right here with the video. Some of them are exact, but some of them are different. So if you have test A, watch the test A video, but you could follow along with this just to get better understanding, better practice. So as we could see on number 10, they ask us to factor. There is no GCF that we could pull out, but we do notice that there's a perfect square term as the first term and a perfect square term as the last term. So we could factor with the shortcut by taking the square roots. Now, I think on version A we had a plus sign right here, which means that it's not factorable. So you'd have to say prime. But right here you could actually factor it. So let's do that. The square root of 4x squared is 2x. The square root of 25 is 5. So if you put both of those right there, and then think about the symbols, one has to be plus, one has to be minus, because the middle term cancels out. And that is all there is to it. That's number 10. Let's move on to number 11. What's the first type of factoring you should always do? GCF. GCF. What is that? What is a GCF? Yeah, and what is a GCF in this case? 2. Okay, what's left over on the inside? Plus 30x plus 9. Okay, so I believe on version A, it was a minus right there, right? Right here it's version B, so it's a bunch of pluses, which does make a big difference. Now, on the inside of the parentheses, you're supposed to continue to try to factor, and you should recognize that there's a perfect square term here and a perfect square term there. And thank goodness that there are perfect square terms, because if there were no perfect square terms, then you'd have to multiply A times C and do that long process. But because it's a perfect square term and a perfect square term, you could square root and plug it into your answer format. So the square root of 5x squared is 5x. The square root of 9 is 3. Because they're all plus, right? There's a plus right here and a plus right there. You put a plus there and a plus there. That makes total sense because a positive 3 times a positive 3 is positive 9. And if you were to distribute and combine like terms, the middle term would end up being positive 30. Don't forget the 2 that you originally factored out. So this is your complete factored form answer for number 11. Number 12 is the easiest type of factoring, quadratic trinomials, because the a value is 1, which means that you could set this up, x, because x times x is x squared. Now the question is, what times what is the c value that if you combine together is the b value, which in this case is negative 1. So you might want to make a list for this guy, right? Negative 1 times 72, negative 2 times 36, negative 3 times, what is that? Negative 4 times negative 5 doesn't work. Negative 6 times 12. Negative 7 doesn't work. Negative 8 times 9. Those are all the possible multiplication problems that give us negative 72. So we need to start combining them to see which pair of numbers gives us this middle value, negative 1. So if I combine the 72 and the negative 1, that gives me a 71, and the middle value is not 71, so that can't work. If I combine these guys, it gives me a 74 or 34. That's not good. Combine these guys, it gives you a 19. That's not good. Combine these guys, you get a 14. That's not good. Combine these guys, you get 6. Combine these guys, you get the positive 1. But you don't want a positive 1. You want a negative 1. So let's change the signs, and we'll be good to go. Positive 8, negative 9. That is your factored form answer for number 12. Number 13, we have 4 terms. There's 2 different types of variables in there. So we're going to try to factor by grouping. So let's first make space between the first 2 terms and the second 2 terms, creating 2 groups. Once again, I've mentioned this before. I see students put parentheses up here. Don't do that. That really just confuses me, and it probably confuses you as well. So let's actually separate the first 2 from the second 2. This is our first group. That's our second group. And then step 2 on factoring by grouping is to factor out the GCF from the first group. So when we look at 12 and 15, there's a common multiple of 3, but there's also x's in both terms, and that makes a GCF 3x. So what would be left on the inside? A 4 and an x. And then the other one would be a minus 5 with a y. Now, on the second group, what could I pull out?
4x.
4?
Oh, just 4.
Just 4.
Yeah.
Now, if we just pull out a 4, what would our first term be in there?
-4.
A -4, right? But notice that on the other one, we don't have a -4x. We have a positive 4x. So it's probably better not to pull out just 4, but pull out a -4. That way, on the inside, you will have the same positive 4x and also -5y over here. So once again, if you were to just pull out a regular 4, you'd have a -4x and a positive 5y, and that would be the total opposite of this. So it's better to pull out a -4. That way, this becomes identical. The binomial becomes identical. And that's what you need to factor by grouping. So you're going to take this binomial and pull them out here in the front. So we're going to put the 4x minus 5 out here in the front, which would mean that we'd have stuff left over. So the 3x would be left over here, and the -4 is going to be left over here. So again, take these two outside terms and bring them down, put them in those parentheses. And ladies and gentlemen, we are done. That is the factored form right there of number 13.
You forgot the y.
I forgot the y. Whoops. Thank you very much. Number 14. Like 2 or like 1. Number 14. Some of us start thinking, I need to multiply A times C, and you get a huge number. But that's not correct way of doing things. In this case, you should recognize that this is a perfect square term and that's a perfect square term. So maybe you could square root them, and the square root of 4y squared is 2y, and the square root of 49 is 7. And then you got to think about the symbols, the signs, the positive or negatives that belong in here. Now, you know, if the signs are different, the middle term would disappear, it would cancel out. So they can't be different, they have to be the same. It's either going to be plus plus or minus minus. Minus minus is the correct option. Now, if you had some time, I would distribute so you could double check your answer, but I know it works. Also, you could rewrite it like this. You could write it like this if you want. Or you could leave it like that. Whatever you want is totally fine. Number 15. Multi-step problem, guys. You have a number out here. It would be nice if you had a perfect square term and a perfect square term, that way you could square root them, but they're not perfect square terms. So let's take a look at the A value of 8 and the C value of 3 and do step 1 in that long process of A times C, which is 8 times 3, which is 24.
6 and 4.
Let me make a list just so everybody understands. 1 times 24 is 24. 2 times 12. 3 times 8. 4 times 6. Those are all the possible ways of getting 24 besides changing the signs. Now let's just go through each one of them and add them together.
-4, -6.
So if I go 1 plus 24, that is 25, which is not what we want in the middle. We want a -10. 2 plus 12 is 14. That's not good. 3 and 8 is 11. That's not good. 4 and 6 is 10. That's great, but we want a -10, not a positive 10. So let's change it to a -4 and a -6. So if you got the right number, but you just got the wrong sign, all you have to do is change the signs of the pair of numbers that you have. Now step 3 is interesting. You jump straight to your factored form answer, format. And what do we put in this first part of the binomial, in this first part of the binomial? 8x. It's the ax value ignoring the square, so it's just 8x. Now, if I had an 8h, then I would put an 8h right here. If I had an 8n, I would put an 8n right there. But this is an 8x, so I'm putting 8x right here, 8x right there. Now, what belongs in this blank spot that I have here and here?
6, 4, -6.
The -4 and the -6 go right in here. Again, the -4 and -6 from step 2 go right in there. And then after that, you could simplify the binomials by reducing by their GCF. So 8 and 4 8 and 4, you could reduce by 2, but that wouldn't be the greatest value you could reduce by. It's actually reducing by 4. And this process technically should be done in your head, but I like to show my work. 8 divided by 4 is 2. You have an x. 4 divided by 4 is 1 with the minus sign. So there's your new binomial. The second one, we're going to divide both of those by 2, and we will get 4x minus 3. And that is your final factored form answer for 15. 16. The rest of the test is about solving equations. And in order to solve equations, if it's equal to 0, you could use a zero product property to split them and set them each equal to 0. Now, before I start solving this thing, I do want to mention this. If you have 1x, you could get x by itself by getting rid of things by doing the opposite. But right here you have 2 x's. So you cannot get x by itself. So you have to move things over, set it equal to 0, factor so you could get multiplication so you could split them and solve. Right here, same thing. There is no single x. There's an x squared and there's an x. So right here, you have to move things over, set it equal to 0, factor, split, and solve. But down here, there's only 1x. So you could move things over and factor, split, and solve. But right here, you could just get rid of things by doing the opposite. Same thing with number 19 over here. There's only 1x that I see, so you could just get rid of things by doing the opposite. The opposite of a square is a square root, and the opposite of a minus 4 is a plus 4. Anyways, let's go back up here to the first one. And it is set up, it's already in factored form. It is something times something equals 0. So you could say at the first something, 4x plus 12 could equal 0. And you could also say that 3x minus 2 could equal 0. So if you subtract 12, you're going to have 4x equals negative 12. Final step would be to divide by 4. So x equals negative 3 is one answer. Plus 2 plus 2. 3x equals 2. Divide by 3, x equals 2/3. Those are your two answers for number 16. So it's really easy if it's already factored. 17, this is not factored yet. And if you start thinking, I want to get x by itself on one side, the problem is you have two different types of x's. You have an x squared and you have an x, so you cannot get x by itself on one side. You have to set it equal to 0 by adding 7x. Now notice you can't add 7x either to the x squared or to the 2, so you're just going to rewrite it. Now it's set equal to 0. Now we're going to factor, split, and solve. Now in order to factor here, since our a value is 6 and our c value is 2, we have to actually multiply a times c, which that would be 6 times 2, which is 12. Step 2 is think of the multiples of 12. 1 times 12, 2 times 6, 3 times 4. And the pair of numbers that adds together to give you the middle value b, which is 7, is the pair of numbers you want, which would be 3 and 4. We move on to step 3 of this long factoring method. Step 3 is to write your factored form format. Don't forget about the equal 0. And in the first position of the binomials, we put 6x without the square. So you take whatever you have here, write it there, and also here without the square. And in the other blank spots, you take the two numbers from step 2, the positive 3 and the positive 4, and you write them right here. Plus 3 and plus 4. Now, it looks like it's in factored form, but we know that if we go 6 times 6, we get 36, not 6. So we still need to reduce these binomials. The first binomial I'm going to reduce by 3. So I will have 2x plus 1. And in the second binomial, I'm going to reduce by 2. And I will get 3x plus 2. And it does equal 0. Now it's completely factored. Now I'm going to split them and solve. So on the left one, I'm going to subtract 1. I will get 2x equals negative 1. Then my final step right there would be to divide by 2. So x does equal negative 1/2. And on the other one, we're going to subtract 2. we're going to have 3x equals negative 2, and then divide by 3, which means x equals negative 2/3. Let's move on. So this was 17. Let's move on to 18. Once again, if you think I want to get x by itself, you cannot get x by itself because you have two different types of x's. You have an x squared over here and an x over here. So you cannot go about getting x by itself. So once again, you're going to have to move things over. So we're going to put the minus 18x and also the minus 20 over here. And of course over here, these cancel out, so you end up with the equal 0. But on the left side, you have to rewrite this whole thing because none of them could be combined. You have a 2x squared minus 18x minus 20 equals 0. Now, some of us are thinking multiply a times c, but that would be a mistake because what's the first thing you should try to do when you factor?
Multiply 2 and 20.
GCF.
That, whatever. Yeah.
So if you pull out that GCF of 2, you will have x squared minus 9x minus 10 left over.
There you go.
Now the 2 that's out in the front, technically, since it's an equation, there's an equal sign here. You could do whatever you want to an equation as long as what you do to one side, do to the other side. So if you wanted to get rid of that 2, you just divide by 2 and divide by 2, and you'd still have the quadratic trinomial equal to 0.
10 and 1 are the factors.
And from here, since the a value is 1, there's no number in front of the x squared, it's really easy to set it up and think what times what is negative 10, that if I combine together is negative 9. Negative 10 and positive 1 is the correct combo. And now that it's in factored form, now that it's equal to 0, now we can split them and solve. Let me scroll up, which means that one answer is what? 10. And the other one? Negative 1. Those are your two answers for that question. Number 18 on version B. If you have version A, it's a different question altogether, I think. Number 20. Do we have 1x or 2x's?
2x.
We have 1x.
What? Oh, like
We have one type of x, right? There's an x squared. So we can get x by itself. So if I have a 36 times x squared, and I want to get rid of that multiplication of 36, I would divide by 36 and divide by 36. That would cancel it out. I will have an x squared equals 25 over 36. Now, wow, I skipped number 19, huh?
Yeah.
I'm sorry. Let's keep going. We'll do number 19 in a bit. So how do I get rid of a square? You do the opposite of a square, which is a square root. Now, we have to remember
5 over 6.
what we have to remember is when you apply a square root in an equation, you have to put a plus minus in front of your answer. Okay, you have to put a plus minus in front of your answer. Now, when you split the root, square root of 25, square root of 36, you end up with a nice, beautiful number, 5 on top and 6 on the bottom. So x equals plus or minus 5/6.
What is that? Plus or minus?
It has to be plus or minus because it's both positive 5/6 and negative 5/6. Now, it all goes back to this original easy equation. Imagine this, x squared equals 9. What's the answer to that? 3. But you see, x could equal 3, but it could also equal negative 3, right?
Oh, negative, okay.
Because if you go negative 3 squared, you also get 9. Just like 3 squared, you get 9, negative 3 also works. So instead of writing the answer 2 times like that, you would just say x equals plus or minus 3. That's where the plus or minus comes from. So from this little example, we know that when we apply a square root in an equation, you have to put a plus or minus in front of your answer. Okay? And that's always the case. Whenever you apply a square root in an equation, you always have to put a plus or minus in front of your answer. So let's go back to 19. That one also has a square root right there. So number 19, because there's only one x, we could get rid of everything and get the x by itself on one side. Again, to get rid of something, you do the opposite. So we have a square right here. If I do a square root of the whole thing, that'll get rid of the square, leaving us with x minus 4 equals. But then again, if you took the square root of the left side, you have to take the square root of the right side. And the square root of 25 is 5. But let's not forget about the plus or minus that belongs in front of our answer. So from there, I need to get x by itself. It's still not by itself. I need to get rid of that minus 4. by doing plus 4 and plus 4. Now, it's not a good idea to get the answer yet. It's a good idea to rewrite it and then get the answer. X equals positive 4 plus or minus 5. And now it'll be pretty clear that plus or minus 5 means this: 4 plus 5 and also 4 minus 5. So the two answers to this problem are 9 and negative 1. So that's about it with version B of the test, the back side, the open response side. If you had version A, then you could look at the other video to find all your explanations of version A. Again, guys, we're retaking this test Thursday. It's your last chance, and it's a great chance, guys. You guys can learn this stuff right now. If you're totally lost, you can learn it now, tomorrow, the next day. Retake it, get an A. It's not all multiple choice. This is open response. It's going to be open response again on Thursday.